All right, welcome everyone. Welcome to Blockchain of Things BoF. Thanks for spending your evening with us. And I have a few slides, so I'm just going to kind of go through those really quick, and then hopefully we'll have a spirited discussion. So if you have a question, raise your hand or just shout something out, and we'll go from there. So just a quick introduction about myself. I'm CTO of Foundries.io. I've been in the crypto space since 2011. Read Satoshi's white paper, was enamored with the idea after the financial markets in the U.S. crashed, and then kind of been working towards adopting, seeing blockchain technology and distributed ledger technology adopted, in the mainstream areas, especially in the embedded areas, which I already work in. So I did some work with the IoT Foundation this summer. I'm talking to the mic. Yeah. So I did some work with the IoT Foundation this summer, and they've got some interesting challenges working with real life applications. So I kind of want to share some of my experiences with you guys, and we can have a discussion on how we get these things deployed in large scale. So the first question you should ask yourself is, do you need blockchain? It gets thrown around a lot, and so there's a nice flow diagram here. I don't know if you guys can see it. You might need to make this a little bit bigger. But basically, it says, are you securing formalized digital relationships, yes or no? If you are, is the data dynamic with an audible history? If the answer is no, then it's static data and it rarely changes, so you don't need a blockchain. Yes, it is a system of record. You proceed to the next step. Should or can the data be controlled by a central authority? Yes or no? Is the speed of transactions more important than the most important consideration? If not, then managing and securing digital relationships as part of a system of record over a layer of the internet is what you actually want, and that's when you need blockchain. So there's a lot of projects out there that may not actually need it. It's more of a buzzword, or it's not really adding value. So kind of go through this flow chart if you're thinking about using a blockchain project. So I was going to do an LWM10 live demo, but the internet here has been kind of hit or miss, so I don't want to try to attempt it. But basically, we have some blockchain-enabled light bulbs. You may say this is a ridiculous thing, but it uses LWM, so lightweight machine-to-machine UDP protocol, and we're able to deploy microservices on a gateway that will essentially put sensor data, model number, manufacturer, software version, serial number, die temp, all that good information immediately on a distributed ledger or blockchain. So basically what happens is the microservice registers for events with the LWM server. As these callbacks are made, it adapts it to MQTT, and then the MQTT stream is read and then published onto the ledger. So typical use case of what you see out there for things that are, sensors that are using blockchain or distributed ledger technology. This is kind of what we've seen right now, and there's other couple of use cases as well. So this is kind of how it looks. So we have our micro platform with a bunch of containers, and essentially it's just one piece to a larger puzzle that's just publishing the data. Where you might want to use something like this is if you have sensitive data that you need to make sure there's a system of record for, whether you're operating a power plant or something very safety critical. It might be a good idea to take a look at blockchain transactions. So the other thing that I want to show you, and I do have a demo for this, is decentralized Git. So I don't know if anybody noticed that GitHub's having problems today. Anybody? Yeah, well, I pushed a repo, tried to clone from it, and then it said it didn't exist. And if I hammered on it a few times, I finally got it to clone. So I actually think this is probably more needed than we actually realize. GitHub and even GitLab services that are provided are a centralized service. Even though they're multi-regional, there is a single point of failure in their load balancers, and it's a single entity that can fail. And there's a lot of code that we depend on for infrastructure projects that's hosted on these things. Does anybody remember the kernel.org hack when the Linux kernel sources were tampered with? Distributed technology, I think, could help there as well. So one of the backbones to this is IPFS, Interplanetary File System. It's a peer-to-peer hypermedia protocol that's trying to replace traditional HTTP protocol. It's got a ways to go. It's still pretty early. It's been around for about 3 years, but it's got some interesting aspects that we'll talk about in a second. So how do you run this stuff? What do you have to do? So you can run it in Docker, and that's basically how you do it. Let me just see if it's actually running here before I get my demo. 1 second. Yeah, okay, we're good. So then I've got a fork of a helper for Git that you can just install with pip. It's Python based, and then you'll have the IPFS remote helper. So how do I import an existing repo? Well, you clone it, you add a remote, and then you push it to a remote. Pretty simple. And then it's going to spit out this hash, which is a hash of the public key. And then you can clone from that public key, and you can add a file, and you can commit something and push it back. Now, the problem is it's not very useful because it gives you another hash, right, which is a pointer to the latest head. And so this is where things like IPFS is working on IPNS, which is a name service, so you can associate URLs or domains with hashes. And so when you do a push, basically what would happen is then the new public key hash would be then updated with IPNS, and then you could pull the latest heads directly from a static URL. So I think that's one piece of it. Now, this is just the storage aspect of it. This doesn't actually give us the web front end stuff. So I'll show you this in a second. So what actually needs to happen to be fully decentralized? So you need a decentralized application, the front end, like GitHub or GitLab for code review, user namespaces, all the fun stuff that we use today. Then you need the IPNS to automatically update the heads. And then you also need an incentive for an IPFS cluster to store your Git objects, which doesn't currently exist. And then you can use IPLD, so it's Protocol Labs has defined a data format for use on blockchains. So you have a blockchain that references IPFS data, and that's how there's a data interchange format. And I mean, really, let's just be honest, Git, if we could get a lot of people using a decentralized Git server, that would probably be one of the ultimate tests of blockchain and whether we can scale to that many users. Think about how many commits are made per day. If we really think this technology can scale and work, then this is a pretty good test, I would say. So before I go on to there, I can kind of show you guys. Really hard to type like this. So we can actually just run through these steps to show you it's not vaporware and this actually works. So this is that LWM to MQTT broker project, just in case you're wondering. So Git add remote. Oops, hang on a second. I actually need to. Oh, sorry, this is really hard to type like this. Wow. There we go. Okay. Okay, so now I've stuck that source code into IPFS on the local node that's running on my laptop. I think that's the important distinction to make here. This isn't replicated across the network now. Now, the way IPFS works is kind of like endpoints, kind of like how Tor works. So if somebody running another IPFS node wants to access those files that I just pushed, they'll make a request, and then that request will be routed across the peer-to-peer network to my node, and then those files will be pulled off there and served through their node. So that's kind of how it works now. So when I was saying IPFS cluster, if we wanted to have a true decentralized Git server, what we need somebody to run a bunch of IPFS nodes in a decentralized way, so not in a centralized service or a single data center. And there would need to be an incentive for those people to store those objects. Because currently, why would you store somebody else's Git repos if there's no incentive to you? So it's kind of the economic model behind how this might work is what I want to talk about. All right, so now that we have this, let's try to clone that. So if I take this guy here, and then I think it's, let me just look at my notes real quick. Yeah. Okay, so then if we go here, geez, that is really hard. And you can see that is the head there. And if we go back, see that's the head there. So I was able to store it on IPFS and bring it back out. Obviously, using hashes for Git repos is really not very human friendly, so that needs to be improved. But like I said, IPNS probably is the way to deal with that. Is there any questions or comments, or is this interesting to people to have a decentralized Git server? More or less? Maybe, how many people use blockchain every day? How many people have used cryptocurrencies or blockchain? Raise your hand. Okay, a good bit of you. Just trying to see where the audience is at here. Okay, so then the next thing I think is kind of interesting, now that you've seen Git object storage on a peer-to-peer network, is over-the-air updates. And I think this is more applicable to kind of maybe the industry that we're in, where we have the need for this on both the Linux side and even smaller devices with RTOS. So the idea here is it's similar to the way the decentralized Git server would work. The nice part about IPFS, it can run on a Raspberry Pi, and it can access clustered data. So if there was an incentive to store firmware and maybe even a manifest that's signed, sorry, maybe I do need a mic to walk around with. If there is an incentive to store firmware updates or manifests that are signed that tell devices which firmware to pull, what would be interesting is a Raspberry Pi or any small embedded device could run an IPFS node. It doesn't have to replicate any of the objects that are in IPFS, but it can access it in a peer-to-peer way. So in a decentralized manner, it can actually pull those files. So what you could do is each IPFS node actually has an HTTP web server that can serve only on localhost unless you enable it to serve outside of the firewall. So what you could do is actually, if your services already consume HTTP data for firmware downloads, you could make a request to the IPFS server to request that firmware object via HTTPS. Now let me just show you what I mean by that. So let's see. So this is the hash that I pushed from my Git repo. Now my IPFS node that's public runs at this URL, and that pulled that file off my laptop. So went out to Hetzner in Germany, came back, and pulled it off my laptop. So the same thing could actually be running on a Raspberry Pi, and you could pull firmware more or less seamlessly because it doesn't have to know about the IPFS protocol natively. It could use HTTP to pull the firmware object and do the download. So you could use OS tree, you could use this with Docker, you could use this with just about anything that uses HTTPS. And I think that's kind of a key point I want to make about software updates is that yeah, this is easily accessible on very small footprint devices. Go back here. So then the next thing I want to talk about is scaling, because I think this is the biggest problem with blockchain distributed ledgers today. This is the arms race that everybody's trying to get to, is who can have the most transactions per second on a blockchain. And I think this is going to be important for doing things like decentralized Git. Ethereum, they basically had to say stop using Ethereum dApps the other day because they're at their maximum capacity. And there's not a lot of users of dApps on Ethereum. So we have a ways to go to improve this. But I think the way we do this is we have to focus on using decentralized technology on the edge. And what I'm getting at here is don't use light nodes and RPC interfaces, right? Because you can have a Bitcoin full node or whatever blockchain network you have, and you're exposing an HTTP interface to do API calls to. But what that's doing is it's creating a centralized point of failure, right? So whoever's using that node or hosting that node, if that goes down, you're going to have to find another node to talk to access the blockchain network. So like what I was saying with IPFS, if that node runs locally and you don't have to store all the files, you can scale all the devices that can access those files because they don't need to store them. They can just fetch them as a read-only way into a decentralized network. I think that's an important distinction to make because a lot of technology, even IOTA included, you can't run a full node with all of the ledger on a Raspberry Pi. There's just too much data to store there. You need too much flash to do that. It's just not feasible. And I think that's part of the scaling is that we need to figure out a way to have devices access decentralized networks without having to store the entire blockchain or have a way of compressing it because it's just not feasible to get into small footprint devices right now. And I'm curious if anybody in here has played around with it and what their thoughts and feedback is, maybe, anybody? Okay, well that's all the slides I had. So I want to open it up to talking about use cases that we've all had or that we're interested in. Maybe there's a problem that we think we can solve with blockchain and you guys want to just ask a question. Anybody?
What were your, I didn't see, or maybe I missed it, the comments about the IOTA infrastructure that you had?
Yeah, so they've got an interesting one. So they have a really neat directed acyclic graph And that's their DAG, and that's where they're storing it. So it's not necessarily a blockchain. But what they do is they have full nodes, right, which basically have the entire copy of the DAG locally, right? And there's an RPC interface that you can access, right? And so you can make transactions through this RPC interface. And so a lot of what technology they've developed is we can run on a Raspberry Pi. In fact, that LWM to M demo that I kind of explained earlier, that's what it's doing. It's taking the data that it receives locally and then doing an HTTP request essentially to a full node that can talk to the distributed ledger and then saying, I'd like to make a transaction, and here is the data that I'd like you to transact. Now, what I'm saying about that is that's a single point of failure. If that node goes down, you have to have a good way of finding another node, right, in a decentralized manner. And that's what you want to avoid. And so it's kind of one of those things that why not build a web service for something like that if you want to store data? Really, that Raspberry Pi should be able to put data directly on the blockchain without having to go to the, well, not necessarily the internet, but to use a peer-to-peer protocol directly from the Raspberry Pi. Does that answer your question? So we've got scaling problems to deal with. Essentially, the Bitcoin blockchain's 165 gigabytes currently. I mean, think about how many embedded devices that would fit on. You need an SSD. Even spinning drives, it's hard to sync the blockchain on those. So you're talking about high performance SSDs. And as the blockchain grows, and Bitcoin's just had its 10-year anniversary, we're at 165 gigs. Just think in the next 10 years. I mean, and imagine if you're putting data into the blockchain, it's just going to only grow exponentially. And that's a problem that IOTA is trying to tackle, actually. So they realized that there's zero fees. There's no transaction fees. There's no transfer of value to put data on their DAG. But what that ends up doing is it creates a lot of extra bloat, right? And so all these full nodes that are running have to store that data. And so what they've come up with is finding the shortest path. So there's milestones in the DAG that everybody gets consensus on, right? And as you're going through, if you can find the shortest path to the data, the transactions that you have made that you want to store, then you can prove to somebody that you've made this transaction, and other nodes can verify that you made that transaction. So some of the use cases they've had is they're working with car manufacturers, and it was making 2 transactions a day to read the odometer in the morning and read the odometer at night, and then put that data on the blockchain, right? And just to be able to do that, they can deal with it now. But when full nodes say, look, I don't have a terabyte of space to store all this data for, they basically take a snapshot of the DAG and they move it forward. So they lose all that immutability, right? And I don't think a lot of people understand that it's not really immutable on their DAG unless you store the whole thing. And so they're looking for ways to say, here's the transactions that I care about, prune the rest of the tree, and so that I can still prove that I made this transaction and that this data is immutable, but I don't have to store the whole thing. So those kind of solutions are what they're working towards. Yeah.
So who would take care of doing things like the proof of work? Why would they do it? In this case of, for instance, distributed Git or other type of blockchain where there is no clear money involved.
Well, so you would have to set a blockchain alongside of IPFS, right? And that's what I was getting at with the incentive, right? And so kind of my off the head thoughts of how I would build this project is you'd create a token with a blockchain, and essentially if you want to create a repo, like I want to go and create a new repo on GitHub, you'd make a transaction on that blockchain saying, here's my 30 tokens or whatever it is, right? I'd like a repo created. And so you put that on there in IPLD format, which is the interchange format between IPFS and the blockchain. And so then the IPFS nodes would see that transaction on the blockchain and say, I'll replicate that, right? Why would I replicate that? Because I want that block reward, right? I want the transaction fee to basically store that data. So they would go and say, I'll take that and I'll create that repo for you and I'll pin it. So then all the cluster, ideally, that wants that token reward, would pin your new repository. So then you'd have space to go push new code. And what they would do is they'd come back and say, here's my proof of replication, right? And then the blockchain would get consensus on, okay, yeah, you've actually replicated, you've replicated, and there'd be a certain amount of nodes that would need to replicate before they would say, okay, here's the payout. So then all the nodes that proved the replication would get the payout. So there would be a financial incentive to do it. Now, there would be no proof of work. There's more of like proof of replication is what would be in place of that. Does that make sense? No, go ahead. If you got a question.
It's okay. It's fine for me. Yeah, thank you.
Like the Filecoin ICO.
Yes. So Filecoin is built on IPFS. Now, here's my beef with Filecoin. I don't think we need general purpose file storage. That would be, there's already coins out there that are doing it, and if you look at the actual numbers of people that are storing files in a decentralized manner, just random files, like there's, Google Drive's pretty good, Amazon S3 is pretty good. It kind of goes back to that first slide is, why do you want to decentralize, right? So I think while they've had a really successful IPO, I think they raised $256 million, they still don't have it released today. But Protocol Labs is the ones that did the ICO, and they're building IPFS, and that technology is pretty good. I think they're struggling with the incentive model of why people would want to store files on their decentralized network. And I think use cases like Git and use cases like software updates are kind of more feasible, and that people can wrap their heads around, oh yeah, no, I would use a decentralized Git server, that makes sense to me. Basically, there's no single point of failure, and I can always access my code. I would pay for that, right? At least I would as a developer. I don't know if I would pay for storage of random files like I would with Google Drive. That's just kind of my opinion. But do you have an opinion on that?
No, but just trying to say it's going to be about half the price.
Yeah, right. I mean, so they have interesting technology and they have really smart engineers working on it. I'm just not sure of the use case of what they're presenting. I like the idea, and I'm really glad that they're working on projects like IPFS because I think those could be fundamental pieces to help scale blockchain. So we can have all of this nice file storage and Git storage and all of the stuff that we want to do, but then also, not have to store it on a blockchain and bloat that entire chain or the ledger. Mike.
Did you have any thoughts on how you show proof of replication over time? Like say a node goes down and you lost,
Yeah,
certain-
so you would have to gain consensus each time you make a transaction, right? And it would be difficult to manage that over time, absolutely, right? You'd want to make sure if you paid for your repo that it stays around, right? So you'd want to make sure that there's extensive. Now, I'm not proposing a white paper on this just yet, right? That whole economic model has to work and it has to be kind of bulletproof before you could implement something like that would scale and that would last the time. But now there's plenty of coins like masternode coins, right, where they, essentially that's what you do is you set up a node that doesn't do proof of work, but it uses proof of stake. And the idea is that there's more nodes because there's a block incentive. And so you get to a point where you have thousands of nodes that are essentially competing for the block reward. But in this case, you would be competing to store your files. And not necessarily like competing, is that everybody that proves replication gets a block reward, right? And so the more nodes on the network, the less the block reward goes down. Those kind of models would need to be worked out to make sure that there's not a million nodes on the network and each single node doesn't get a whole lot of payout and it's not worth it to run a node anymore. I mean, when you build a project like that, you kind of have to look at where the sweet spot is and how you could design a project to meet those needs. Yeah.
What's your view on blockchain 3.0 like Cardano?
Yeah, so that's interesting, and like even Lightning Network 2 is pretty interesting stuff. I think, there's two camps. There's on-chain solutions are the only thing that is going to work. I kind of lean the other way a little bit, saying I think off-chain solutions have their merit, right? So Cardano's a good one. The Lightning Network's a good one. Even IPFS is off-chain, right? I mean, it's basically synchronizing between blockchains and another service, right? So I think you need to have the immutability somewhere in that root of trust, right, anchored, which I think blockchains do really well, but necessarily for the transaction speed and the scalability, that we can't have it on chain, right? Until somebody comes up with another technology to do it completely on chain, then we're going to have to look at these off-chain solutions.
So on that Git helper, when you're like fetching objects down, are they all going to have to live on like one node of that, or?
Well, so yeah, the idea would be so currently the way it works, it's living on my node here in my Docker container, right? The idea would be that you'd have a blockchain alongside of it to say, okay, I would like to start this repo, and every time you make a commit, you'd have to make a transaction saying, here's the new head, please update it, and then proof of replication for all the nodes, reach consensus, and say, here you go, it's all replicated. So you basically get like an ACK back to say it's all replicated.
So, but when you're pulling down, like, would the entire transaction be between you and one server, or it might get like one of the SHAs from one place?
It's like Tor almost, or like any.
Yeah, well, that might be kind of neat if, like, if 1,000 people are all storing the same kinds of repos, you kind of
you spread the load
dedupe
out,
the
right?
data
Yeah.
or something.
Yeah, I mean, it would be interesting to do a study on, how fast IPFS is compared to traditional Git. I mean, when you throw decentralization in there, you're going to lose performance, but I'm curious by how much and how long it would take to replicate over 10,000 nodes, and those kind of things need to be explored. But I do think it's worth thinking about because, I mean, today I had all sorts of problems with GitHub. Now, granted, that doesn't happen all the time, but if it's ever controlled by a single entity and there's censorship involved, that's where you kind of want to look for decentralized solutions. So if there's developers that are being censored and they can't work on certain software, this decentralized Git server idea might be interesting to them and actually solve a real problem. Yeah.
So you've been talking about scaling. That is the next biggest challenge in blockchain. And so you mentioned that Ethereum doesn't scale very well, and the throughput is quite low, actually. So I've seen that project like EOS, for example,
Yeah.
where throughput looks like much higher than Ethereum, for example, but which are more centralized.
Yes.
So what do you think is the right combination of parameters to solve this problem of scaling? Is it throughput? Is it decentralization? Is it actually to find the right balance between those parameters which could solve this problem, or what are your thoughts about it?
Yeah, no, I think that's a good example because so for people that don't know about EOS, there's block producers, right? And they're the ones that produce blocks which have rewards, and then they share them with people that vote for them. So basically, they're like elected. It's like a delegate system, right? So that can allow those kind of architectures can allow for higher transaction throughput, but at the loss of some of the decentralized nature of like proof of work blockchains. So it's an interesting concept. And I personally, my view is that there's a balance of it, right? And finding that balance is difficult because there's kind of two camps where, I would never use EOS because it's completely centralized, and the other camp saying, well, yeah, that's true, but look at what it can enable, right? It can enable much higher throughput than traditional blockchains. So I kind of fall somewhere in the middle. I think we're hopefully going to find a better way to do the delegates and voting. I think there's been a lot of criticism on EOS on how block producers were getting voted in. And personally, like what I've seen with master node coins are pretty interesting is that there might be a tier. So there's nodes that help produce blocks, and then if you have one of those, then you can vote to elect certain people. So it's done in a decentralized way. They did it in person, not through a blockchain. So I'd kind of say maybe to move to that model that you use the blockchain to do the voting to have the delegates. So Tron's an interesting one. I know Tron's kind of a strange beast out there, but I actually did some looking into it lately because they started their mainnet, and they have kind of a similar idea with their block producers, except they have more of them. So I think that's, instead of having 28, I think it is block producers for EOS, having 1,000 or 10,000 might be a better solution. That way it dilutes the power of a single block producer. And they also had problems like there was a critical software update where all block producers had to update their nodes and run certain software. And, guys like, I'm on vacation for 3 days. Sorry, can't do it. And so it cost people money because they end up losing money based on a vulnerability that wasn't patched. So those kind of things really shouldn't happen on a blockchain. You shouldn't have to, I'm going to manually update my software to do this. So you get kicked out of consensus is really what should happen, and your node no longer can produce blocks if that's going to happen. And there's a critical network upgrade that needs to be deployed. Well, good question. Maybe I'll ask a question to the audience. So we're all here for embedded Linux and IoT. What platforms would you guys like to see blockchain on? What use cases? Maybe aside from the decentralized Git and over-the-air updates, is there any other use cases that would be interesting in kind of our realm? Other than value transfer, right, and censor-proof money.
It might be kind of cool if you made that backing store instead of just being like this. Maybe like just content addressable, like S3.
Well, yeah, that's essentially what Filecoin is shooting for, right? Is a content addressable file.
There are like JGit, there are other like implementations that know how to talk to those kind of backends. That's all Git's doing.
Oh, that's a good idea. Yeah.
And then you could like decentralize. You could almost like have 20 threads grabbing SHAs from everywhere.
That would be nice. Yeah, it would be, I mean, it's a science project that I'm gonna continue to kind of analyze, but yeah, those kind of things would be really neat to be able to see if, because it's decentralized, like you're saying, that you could actually multi-thread it and be able to pull stuff a little bit
You
faster.
might get other speed, you know, you're always gonna be slower, figuring out what you've gotta grab, but then you do faster.
So you've done a lot of Git, right? Doing infrastructure for Git. I mean, what's your experience with centralized Git servers? I mean, is Git hard? Or?
No, it's awful to serve. It's like, if you have to serve a Linux kernel, it takes lots of RAM, lots of compute power.
Yeah.
But that's just for like that first part, because the client kind of says, hey, I have these things, tell me what I'm missing. And then the server,
Gotta go.
it does that calculation at the start, but then just shooting it all down.
Yeah. So is that where you see the bottleneck is getting the data moved?
It's kind of interesting.
Yeah.
I've never tried it, but the JGit project has a backend that talks to like S3, and I always was curious like how that would be going.
Yeah, I mean, an object-based file system would work really well with IPFS. So they do have some work ongoing to do actual mount points. You could mount an IPFS file system, and so you could actually just set a Git server right on top of that if you wanted to, but then you still don't have a way to have other nodes in the cluster pin your data, which is really, I think, the important bit there. All right. That's all I had. Is there any other questions?
Why do you think that Hyperledger has joined into Ethereum Alliance?
That's an interesting question. I actually don't have an opinion on why they joined. I think Ethereum is looking for any way to scale that they can, and they're looking at ZK snarks, right, off-chain solutions. They're looking at Hyperledger, it sounds like. I think they're trying to test the water. I mean, they have that proof of stake update that they thought was going to help scaling that hasn't gone out yet, that sat on testnet for a while, and so it's interesting. I think that they're just trying to kind of look at all the technologies and try to figure out what's going to be the next one. I don't think they've made up their minds at all on what it actually is and how they're going to achieve it yet. So this space is still, while it's been around for 10 years, is still very immature, especially on the DApp side and the scaling side. So I guess in closing then, I really hope to see useful applications built in the future on top of blockchain and distributed ledger technology. They're big problems to solve, but I think with enough smart minds kind of focusing on real use cases that we can actually achieve that. But again, there's no silver bullet here. This isn't the technology that's going to save you or help you ship product faster. It's still very experimental. So thanks for your time, everyone.